Welcome back to my channel, everyone. 3 tips here. I've got an old melt dish. We're going to zero the scale out. I've got some scrap 14K material, karat gold. I'm going to add this to the melt dish. See, we've got 65.5, and I've got that recorded over here. Now what we'll do is zero this out. This is 10K material. Add that to the melt dish. And we've got 82.2. I've got that recorded over here. I've calculated that I need this much silver, 135.1 grams, to properly quart this much gold. And I've pre-measured some silver that we're going to use to quart our gold. 135.7 grams. I've calculated 135.1. That's close enough. All right, here we go. We're going to put our scrap gold under the torch and begin to melt this up so that we can add the sterling and quart the gold. pouring the water off here. I'm going to transfer the gold into this beaker carefully. And then what we'll do is rinse this out several times with distilled water to get all the tap water rinsed off. And then here's what our encorded gold looks like. Here's the gold that we've encorded with silver. And I've got some used nitric acid from a previous refining. We're going to pour this right in now and start pulling out all the silver that we just added, plus any silver and base metals that were already in the karat gold. Set this up on heat. This will be our first nitric acid boil. Nitric boil number 1. The reason we add silver to the gold is to dilute the gold concentration in the alloy so that the nitric acid can penetrate to the core of each piece of encorded gold. It will remove all of the silver that we added, plus any silver and base metals that were already in the alloy of the karat gold. First nitric acid boil is complete. Pour this off now into our silver jar. Because there's going to be silver in this solution that I'm pouring off, I want to save it and recover the silver. And now what I'll do is add a little bit of distilled water, set it back up on the heat, and now I've got some nitric acid. I'm going to pour some nitric acid in here. And this will be nitric acid boil number 2. I think nitric boil number 2 is complete now. Let's pour this off into our silver jar. Add some water to this. Distilled water. And then some more nitric acid. This will be nitric acid boil number 3. Nitric boil number 3 is complete. Pour this off into our silver jar. Add some water. Put it back up on the heat. Add some nitric acid. And this will be nitric acid boil number 4. Nitric boil number 4 is done. You can see the color of the solution is beginning to get lighter and lighter as more and more of the silver and the base metals get pulled out of the gold. It's looking pretty good. That's how the gold's looking down in the bottom of the beaker. And what we'll do now is one more nitric acid boil. That's distilled water going in. And now what we'll do is add some more nitric acid. And this will be nitric acid boil number 5. Nitric boil number 5 is complete. You'll notice that there's a little color going on down in the bottom of the beaker. So we're still pulling a little bit of copper. If we're pulling copper, that means we're probably still pulling silver. So we're going to pour this off now to our silver jar. Here's our gold down in the beaker. The stuff is looking very good. After all the silver and base metals get pulled out, the resulting gold down here will be very close to 3/9 fine, just like it is, without any further refining. But in order to get it to 3/9, we'll have to refine this in aqua regia. Now we're going to add some water, set it back up here in the heat. Now I'll add some nitric acid. And we'll do nitric boil number 6. Number 6. Our solution is looking colorless now, and that tells me we pretty much got all the silver and base metals out of here now. I'm just going to pour this is nitric acid in here, dilute nitric acid. We're just going to add this right into our silver jar. I've got silver in there that will consume all of this nitric acid for me. All right, that was distilled water that I rinsed the gold with. Adding some more distilled water. And we're going to put it up on our heat source here and boil the gold now that it's got all the silver and base metals removed. We're going to boil it in distilled water. The gold is boiling in distilled water, and we'll let that boil for a few minutes. What I want to talk about here is this silver solution that I have in my silver jar. It's going to be silver nitrate. The blue color comes from the copper that dissolves out of the sterling silver that I add in there. I've got some pieces of sterling in there right now, and they're consuming the excess nitrate that is in that solution. So every bit of the nitric acid that I use in my gold refining gets used to dissolve the silver in my silver jar. Once the reaction is complete in my silver jar, what I'll do is I'll filter it to remove any solids, and then I'll take the blue silver nitrate solution. It's blue because of the copper, but there's mostly silver in there. What I do is I filter it, and then I add it to a beaker like this, and I add pieces of copper to the silver nitrate solution, and I get cement silver, which is this gray material down in the bottom of this beaker. It's high purity, about 99 to 98% pure silver powder. And then once I get all that blue liquid rinsed off of there in a funnel, I melt it into shot like this. This is impure silver shot that I've melted from the 99 to 98% cement silver from that jar. And then I add these granules. I melt it and pour it in water to get these granules. And then I add the granules into my electrolytic silver cell. This is the anode basket that contains the impure silver, these granules. I feed them in here, and we pass an electric current through there, and the electric current dissolves the silver, and the silver ions are allowed to travel through that Dacron filter bag. Here's the power supply that I use for the electrolytic silver cell. Keep it set at 3.5 volts DC, and the amperage falls where it may depending upon the conditions that vary in the silver cell. I've got an inline 3 amp automotive type fuse there in the circuit that goes down to the electrode bar in the anode filter basket. And then if you look down in here, this thing has been running for 13 days. If you look down in here, it's full of high purity silver. And I've been knocking the crystals down and just letting this thing run. Those are high purity silver crystals that form as the electric current passes through the silver up here in the anode filter basket. It dissolves. The silver ions are allowed to pass through that Dacron filter. But any other metals that are in here, such as platinum group metals and gold, they get trapped in that filter, and I save those and process them later on. But if you notice, this blue liquid in here is silver nitrate solution. That's what we use for the electrolyte. The silver ions that pass through the bottom of this filter basket, they travel through that electrolyte, and then they plate out as high purity silver on the inside of this stainless steel bowl. All right, the whole entire stainless bowl acts as the cathode for the electrolytic silver cell. And then over here, I've got the cathode connection. There's just a copper strap fixed onto this stainless bowl with a hose clamp, and that goes to the cathode goes to the negative side of the power supply. And this thing runs constantly, and it cranks out about 1.5 kilos of high purity silver every 10 days or so. That electrode bar in there is a pure silver bar that I've cast with a copper wire, number 10 gauge copper wire, right around the bar, so I get an excellent connection. And then we just sit that down into our anode filter basket. And as long as we keep the electrode bar up out of the electrolyte, which is getting pretty close to coming in contact with the electrolyte, you can see part of the bar was in contact with the side of the filter basket there that's saturated with electrolyte, and it started to dissolve. So if we keep that bar up out of the electrolyte and away from the sides of the anode filter, then we can use this bar over and over. You can actually see some liquid down in there. So it's what that's telling me is it's time. I don't want to add any more silver into that thing. I'll probably go ahead and harvest the crystal out of here tomorrow, day 14. It'll be 2 weeks it's run, and I'll make a separate video of the harvest of the pure silver crystal out of our electrolytic silver cell. This has been in here boiling about 15 or 20 minutes now. So what I'll do is I'll pour this distilled water boil off right into my silver jar. This just helps clean it up, get some of that more of the nitric acid off of here, and maybe a little bit of silver that might still be in there. Alrighty, this is our gold down in the bottom of the beaker after 6 nitric acid boils. That gold right there, you could melt it up just like it is, and that would be very close to 3/9 fine without any further refining. Now that we've got all the silver and all the base metals removed, I'm adding hydrochloric acid to the gold. I'm going to put about 400. I'm going to fill it up to the 400 milliliter level. Now I'll add a little bit of sulfuric acid. Sulfuric acid will precipitate out any lead that may be present so that we can filter out all of the lead that may be in there 100%. I've calculated the yield on this to be about 70 grams or so of pure gold. So what we'll do is we're going to add about just a little under 40 milliliters of nitric acid. I'm going to add that right on in, and then we're going to cover this up, set it up here, and let this dissolve. There's still quite a bit of gold in there, and I can tell the reaction is complete because all the fumes have cleared up in our beaker. And so what we're going to do is going to add a few more squirts of nitric acid. And on the comment section, I've seen where folks are asking, how do I neutralize excess nitric acid? And the answer is, I don't neutralize excess nitric acid, because what we're doing here is using incremental nitric acid dosing. What that means is I'm adding just the right amount of nitric acid in here to just dissolve the gold. If I do this correctly, there's no need to add anything in here to denox the solution. Denox means remove excess nitric. If I do this correctly, there won't be any excess nitric in here to remove. However, if I do overshoot with the nitric acid additions, and I do that every now and then, get too much nitric in there. The best way to get rid of it is to just evaporate the solution down to a syrup until no more fumes are being evolved, and then rehydrate it with some hydrochloric acid. Incremental nitric acid dosing is one of the most valuable refining techniques that I've ever learned, second only to quarting with silver and parting out the base metals and silver with hot dilute nitric acid boils. Here you can see we've still got just a few little stubborn pieces of gold that haven't dissolved yet, and the fumes are starting to clear up in here. So what we're going to do is we're going to reach down in here, grab just a few little, less than half a milliliter of nitric acid. I'm going to put it in here and drop it in down on top of our gold. Let's see if we can get the rest of that to dissolve. I just added another little shot of nitric acid. You can see here the last few bits of gold are starting to go into solution now, so I've cranked the heat up a little bit. We'll just wait till we get everything dissolved and go to the next step. All the gold has been dissolved now in the aqua regia. So what we're going to do is we're going to pull this down off of the heat and let this cool off. If you look down in the bottom of the beaker, there's some phantom pieces of gold. They might not even be gold. It might be just some trash that was in our carat gold and our quartz gold. I call them sucker pieces because if you don't know any better, you'll sit there and keep adding a whole bunch of excess nitric to it to try to get that stuff to dissolve, and it never dissolves because it's not even gold. So what we're going to do now is add some ice to this to cool our solution off. I'm using a number 2 medium flow filter. It's 11 centimeters in the Buchner funnel. Now we've got our gold cooled off to about the temperature of a cold glass of iced tea. Not a whole lot of cloudiness in there, and that's a testament to how effective it was pulling the silver and the base metals out with our nitric acid boils. So now we're going to filter our solution. Now the filter paper is loaded up with all of that particulate from the first filtering. What that means is all the pores in the filter paper now are clogged up with trash from this first filtering. And what we'll be able to do now is pour the gold back through the same filter a second time. Pour it back through the same filter a second time, and we'll be able to get more of the suspended solids that's in this solution. It's not bad looking. It's got just a slight hint of cloudiness going on in there. So we're going to pour this back through the same filter for a second pass. See if we can get a little more of that cloudiness out of our solution. Here you can see the difference that second pass has made through the same filter. This has just got a ever so slight bit of cloudiness. This solution down here is absolutely clear and bright, and that's the benefit of pouring the solution back through the same filter a second time. We may as well do it while we have it in this state. The suspended solids in the solution is probably silver chloride. Got all the solution pulled through the filter, and I do not want to rinse that filter with some water, because silver chloride is slightly soluble in warm water. So what we're going to do is I'm going to transfer the filter to this first flask. This up out of the way here, and I'll rinse this filter down into this flask with some distilled water, get all the gold out of here, and then I'll just probably end up adding this to my stock pot or my temporary waste container. I've got a clean beaker here with some ice in it. I'm going to add our gold solution to it. Look at how clear and bright that is. Beautiful. Okay, here we go. We're gonna precipitate the gold with some sodium metabisulfite. Here we go. We're gonna just add our first spoon right on in. Start the precipitation. One more spoon. Three. 4. 5. 6. 7. 8. 9. Looks like we're getting pretty close to being done here. There's our white foam. That should do it. Give this a little stir. It does generate some heat. And now I'm gonna, this is a piece of filter paper, stick it in here, get some of that on our filter paper. And I've got some stannous chloride testing solution here. Let's make sure we've got everything dropped out of our solution. See, there's no reaction on that filter paper with our stannous chloride testing solution, so that means all the gold has been precipitated out of that solution. The gold has been allowed to settle for about half hour. Now what we're going to do is, I've got this funnel cleaned out, get it out of the way. Here's our temporary waste container. I'm just going to add this little bit of gold solution into here, and I'll recover this later on. Now let's pour off this waste solution. And here's what our pure gold powder looks like. Now I'll rinse the gold powder with some distilled water. Adding some hydrochloric acid to the gold. I'm going to set it up here on the heat now. And we'll just boil this gold in some hydrochloric acid. We've had it on boiling in hydrochloric acid now for about 15 minutes. Now what we'll do is go ahead and pour this off into our waste container. And now what I'll do is rinse it over and over with some distilled water. Alright, here's how our gold looks now. Nice reddish caramel brown color, just beautiful. Alright, let's get our gold down into a melt dish. Get that water out of there. Let's take this over to the melt table now. Look at that beautiful gold powder. We're going to melt this up into a nice gold ingot. Here is the pure gold bar that we just poured. It looks spectacular for a single refining. Very nice. We were expecting 72.5 grams of pure gold. 81.5 grams. That's almost 10 grams, 9 grams more than we were expecting. The only thing I can think of is one of those heavy bracelets that I had in the scrap. Had a catch on it marked 10K, but the actual bracelet was 14K. Beautiful. All right, this will conclude the video. Thank you for watching.